Cameron here again. This part of the video is about controlling the stepper motor using a software called LabVIEW created by National Instruments. What LabVIEW does is it allows us to create what is called a virtual instrument, or VI for short. This VI consists of a graphical user interface which is contained in the front panel. The front panel makes it very easy for anyone to interact with the program. It consists of various controls and indicators to allow for the user to control and understand the virtual instrument. On the right side, we have the block diagram. The block diagram contains all the programming and procedures required to make the front panel function appropriately. As you can see, the programming aspect of LabVIEW is not text-based at all. Instead, it's more of an iconic approach in which you can drop in a certain function or process, such as this dial control. In this scenario, we have the dial connecting to the case statement. The case statement is this box right here around the true and false constants in the center of the block diagram. The case statement really just allows us to create various scenarios for each of the cases. As I switch through the cases, you can tell that the values of the constants are different for each case. These constants are the control of the different phases for the stepper motor. From right here, the data is output to the NI MyDAC using DAC Assistant, which are these icons over here. Also, for the purpose of virtual interface, we have it connecting to these LEDs. Now, I will execute the program in highlight mode, which will basically allow you to see how the data is transferred from the different controls to the rest of the program. As you can see, this dial is going to change the case statement, and these constants send out the data to the rest of the program. And as I change the dial, there's a new case to have the data sent out from. You may notice that the VI is running really slow and that the LEDs are taking quite a while to refresh and display the new information. This is because highlight mode has slowed down the program, making it easy for us to understand the process. I will, however, before showing you the stepper motor, turn off highlight mode, and you will see that the process speed increases tremendously. You can tell as I spin the dial that the LEDs are constantly changing, representing the different cases. Now, I will continue to spin the dial as Denison transitions to the stepper motor.